What's up, guys? We're on our way back to the shop right now. I got my camera with me. We're gonna go make some more Surron parts. So this is what I want to make today. It's a 3D printed prototype of a rear set and peg for the Surron. So this is actually going to be a 3-piece part. We're going to have the back plate, like I've cut out here. Then we're going to have the mount, which bolts onto the plate in there. This is just printed one piece, it will be machined 2 pieces. And then obviously we'll have the peg. So the back plate is actually going to be a very easy part to do. I'm going to cut the initial shape out on the Waterjet like this, and then we'll put it in the machine, bevel it, engrave it, drill and tap it, and yeah, that's it for that one. Alright, here's our parts. I cut them out on the Waterjet because I'm trying to make these affordable. Right, so I could make these entirely billet out of a big plate and cut them so they're entirely made in that machine, basically. And they'd have some better edges and stuff. But I'm hoping that these turn out they turn out good enough, you know what I mean? And not to say that in a negative way, but like I said, I want them to be affordable. Now, I've got this little hex here on the back because that is going to be my cross brace. Right here, I got some hex stock. And once again, obviously I could do some big extravagant crossbar brace here, but this will just bolt right up there and will look pretty cool for not having to do much work to it. Alright, here's how we got it set up in the vise here. Obviously not ideal, but it's going to work for now. Eventually I'll make soft jaws, which would be taking off these steel vices and machining aluminum ones that fit this contour perfect so that you could just drop them in and go. This tool is pretty cool. You can see it's kind of like a router bit. It goes around the outside of that part and leaves a nice rounded edge. You can see the difference there on the left versus the right. Do you expect me just to hold you like this? I guess she does. Here's our finished part. Pretty easy. So our 2 parts here are done. you can kind of see the inconsistency of the Waterjet finish and the machine finish. So I'm going to throw them in a tumbler and try and even that all out. Alright, what we got here is just your typical Harbor Freight tumbler, and I have a mix of sand and some tumbling rocks in there along with our parts. We're going to let this run all night long and see what they look like in the morning. Here's how these parts look after coming out of the tumbler. You can see it kind of evened out that texture from the machine finish to the Waterjet finish, and they look not bad at all. Next up, we gotta make this part, which bolts into that, which holds our peg. And if I come up here to the assembly, there's our plate, there's our hex rod, and there's our peg. So here's what I'm working with for stock. It's way too big, but it's what I got laying around, and for the first part it's just fine. We're gonna use it. And just like that, here's our first operation done. I'm gonna roll the part over on its side, drill this cross hole, and then we'll flip it over and finish the bottom. It's a pretty simple one too. Fast forward a couple steps, we've got our parts here. And if you look, it's pretty cool how I did this. See that little outset and inset? So when that sits in there, it can't rotate. It's a perfect fit. So when we take our bolt here, boom, and that's our finished product. However, I realized I messed up on these. That radius that's down there, that radius is supposed to come right up and hit this flush, so it looks like it's one piece, right? I'll show you what happened. Back here on the computer, you can see what I mean, how that fillet is supposed to come right up and meet with this one, so it's a nice like one piece look. Well, when you go and measure this radius, I set it as an 1/8 inch radius, right? The radius measures an 1/8 inch. So I thought I should run a 1/4 inch ball end mill around this, because typically radiuses are half of the whole thing, right? Wrong. I'm supposed to use an 1/8 inch ball end mill. I have cut out a couple more pieces. Let's do it again. I 3D printed these little rings. Slide right over my tool here, right over the collet, and they allow me to pry my collet right out. But right here, this is our collet. That goes in our tool holder. Our tool goes in here, and when you tighten it, it compresses these slots and holds onto that tool. So we'll swap out this 1/4 inch for this 1/8 inch. Here's our new part. You can see the difference here between our one we put through the tumbler and our new one. I think I'm gonna skip the tumbler on this one because I just slowed the feed rate down on the Waterjet and I got a lot nicer cut out of it. So I think we're just gonna run it. And if we take our other part here and mate them together, it's a very tight tolerance here. Look at that. Fit together and don't even fall out without a bolt. But as you can see, look how nice that radius looks now. And once we put this bolt in and tighten it down, it's gonna look like one piece. Check that out. Here we can watch the simulation of the pegs. You can see the stock we started with, and this simulation is really cool to watch. It gives you a lot of helpful information. This part here is pretty difficult to do on a 3-axis machine because of this 45-degree slug on the end. The 3-axis just can't get to that part. I'll show you how we're going to do that later, but for now we'll get everything we can. Alright, so I've already machined this one. You can see it looks exactly like the simulation does. We got to finish up that slug in there, but how cool does this thing look? I put those studs in there for our foot grips. Those are just set screws, and you can see those cool tool paths on the bottom. These things look sweet. So next up, we got to figure out how to get rid of the rest of this material here in this slug. You can see my vise is over here on a nice angle, kind of like exactly what we need. So this is our angle plate. This puts my vise at a 45-degree angle, so when I put my part in here, it's at the perfect angle to go straight down in and get that hole, and then we'll flip it around to this side and machine out that cavity. Definitely the hardest way to do it, because on a 3-axis machine, this is a 4-operation part, meaning I have to take the part out, flip it, turn it 4 different times to get our end product. But we're working with what we got for now, so let's get it done. Is that pretty or what? They look so cool. So I'm planning on either anodizing them, or I thought about Cerakoting them. Anodize always seems to fade, so I'm gonna try that, and then so that'll be really cool because everything will be black except for the studs, the spring, the pin, the bolts. I think it'll be a really cool look. I think I might call this video here for now because I imagine it's getting pretty long. We'll show off these painted and completely done in the next video, as well as showing off our cool axle sliders. Those should be done by next video too.